y double dashed plus 8y dashed plus 25 equals 0, and we've got these initial conditions. Let's write down the associated auxiliary equation here then. Lambda squared plus 8 lambda plus 25 equals 0. Now let's use the formula to solve it. Lambda equals minus b, so that's minus 8 plus or minus the square root of b squared is 8 squared, so that's 64, minus 4 times a, which is 1, times c, which is 25, all over 2 lots of a, which is 1. So we end up with then minus 8 plus or minus 64, take away 100. This is 425, this is 100. That's minus 36. 36 is a square number, so we can square root that, and we've got a minus 1 square rooted, haven't we, to times it by, because it's a negative 36 here. That's over 2. So that implies then lambda equals, what have we got? Minus 8 over 2 is minus 4, plus or minus 6 over 2 is 3i. So alpha plus or minus beta I, remember, from the solution for case 3. So we've got case 3 here then. There's our alpha and beta. Case 3 gives complex roots. So let's have a look at the case 3. Here it is here. I just moved this up slightly. Here's case 3. And that's what we've got here. A sine beta x plus b cos beta x times e to the alpha x. So let's write that down then. So what have we got then? Y equals a sine beta, which is 3, plus b cos 3x, all times by e to the alpha x, wasn't it? And alpha this time is minus 4 for alpha. There we go. So there's y. Now let's invoke the initial conditions. Y naught equals 2 is the first one. So at y naught equals 2, put 2 in, y is 2, when x is 0, sine naught, 3 times naught is 0, sine naught is 0, cos naught is 1, so that'll be a b, times e to the naught, isn't it? So that's 1, so b is 2. There we go. That's what we get from the first initial condition. Now we need to differentiate it. So differentiating then. Gives. Okay, what does it give? Y dashed. So I'll put it over here to give me some room. It's a product. This whole thing is going to be the product u. And this thing here, this function of a function is v. So it's u which is that, times the v dx, which is the minus 4 comes down, e to the minus 4x. That's u to v dx plus v, which is e to the minus 4x, times du dx, and there's two terms in here to differentiate. Sine goes to cos of something, sine something goes to cos of something, multiplied by the something differentiated. So the 3 comes out, doesn't it? So we'll have 3a cos 3x, and here the cos goes to minus sine and the 3 comes out. So we'll have minus 3b cosine 3x. That's what we've got. So that's y dashed. Now what was the initial condition for y dash? Let's just go back and get it. Y dash naught equals 3. Let's put that in here. So y dashed naught equals 3 gives, let's see what we get then. So here's y dashed, that's the value of 3, is equal to sine of naught, because x is naught, so that's naught. Cos naught is 1, so that's a b, times minus 4 e to the naught. So that's times minus 4 e to the naught is 1, so that's okay there then. Plus e to the naught, which is 1, so we've just got this bracketed stuff here, times 1, which is just the object itself. This is a sine here. U dv dx plus b du dx, and that went to cos, and this part here is sine, so I better write that in. and correct that. I should have written a sign. I probably mentioned it as a sign and wrote cos. Anyway, that's what it is. So what are we doing? We've done that. Plus e to the naught is 1. And then you've got this bracket. 3a cos naught. And then sine naught is naught. So what do we get then? We get, this implies, just tidying it up, 3a minus 4b, reading from right to left, equals 3. We know that, let's just flick back up b as 2, there it is there. So that implies then a equals, move the minus 4b over to be with the b, 3 plus 4b, and then I'm going to move, once I've done that, I'm going to move the 3 from time to divide, and just written it down in one fell swoop. The b was 2, so that's 3 plus 8 over 3, which is 11/3, which we can leave as is, simple fraction. So then, the answer then, this is the particular solution. A is 11/3, so it was 11/3 a sine beta x, which was 3x, plus b, which is 2, cosine beta x, all times by e to the alpha x. I'm just going to go back up. I think it's 2, but I'm just going to check what alpha was. Oh no, it's minus 4. Here it is here. A and b, and it's e to the minus 4x. So there we go, put that in. A was 11/3, b was 2. So there's the final particular solution.